Hey guys, Tal from Takipi here. So I'm going to do two kind of quick things today. Give you, those of you in the room who don't really know what we're doing, kind of a sense of what we're doing. And I want to share some new project we're working on with regards to reactive programming, which is really taking hold within the industry. So I want to share some of the work we're doing there. This is us, founded in 2012, headquartered in San Francisco here in Heavybit with R&D Center in Tel Aviv, backed by Menlo Ventures. For those of you who don't know what the meaning of Takipi, the name is, this is Taki, this is Takipi, company dogs, and the reason why we are so named. What is it that we do? So we all know the challenges of running modern, distributed, scalable systems. Code being continuously deployed, continuously broken, everything is async, everything is distributed, and we have errors within large applications thrown from hundreds of locations. Some of them are minor, some of them are critical. And it is really our job as the people building and running and operating those systems to be able to focus in and understand very quickly which of those are critical ones, which we need to address right now because they were introduced in last night's build and are on their way to production versus which ones have been around the system for 3 years and frankly nobody cares. So we want to be able to help companies identify the risks and then give them the tools they need to fix critical errors in their code. And how do you fix errors in code? We all know that. We have to give engineers the actual information they need, which really means three things. It means a combination of stack, source, and state, which are the three key components engineers need in order to be able to move ahead and fix systems in production. And this is essentially what we do as technology. We build a technology, Takipi does it, detects all errors in live production code for Java, Scala, and JVM-based language. It gives engineers and DevOps engineering managers powerful analytics to cut through the noise and get to the errors which are most interesting to them, and then give the engineers the actionable information they need to fix those errors. So this is kind of a very kind of crash course on what it is that we do. And I want to show you a 1-minute demo and then show you a project we're working on that's related to reactive programming. So let me switch gears very fast here. So what we have here is a dashboard for an actual live production system. This is us running on us. And you can see all the errors that the system is currently experiencing. And one of the nice things about Takipi, it gives you a very powerful engine to very easily run sophisticated queries on all the errors, all the bugs in your system which are happening live. Like, show me all the errors which were introduced over the past day, for example, and are either caught or uncaught exceptions. So across the entire cluster, in production and real time. So you can get, and there's many, many different things you can do and a lot of powerful analytics you can cut to really understand what are the things that you as a team should be focusing on. But again, we want to really make it quick and get to the second point. Once we've detected something and prioritized, what happens if we click and zoom in to see, to look into actually one of those. Here comes the interesting part, which is the system can automatically reconstruct that holy trinity, if you will, of stack, source, and state at the moment of error. So we can actually transport engineers into the moment of error in production right as if they were there and show them variable state across the entire call stack. One thing that we've introduced, and this brings me towards our work within distributed systems and reactive programming, one of the things that we've done this year is put a lot of focus on those kinds of applications. For example, a recent addition to the product is something we call unified call stacks, which is we're used to the Java virtual machine or every software runtime, giving us a call stack when something breaks. But those call stacks are always confined to a single JVM, a single VM running on a single node. So one of the things that we've introduced this year is a notion of unified stacks. This call stack actually spans. It starts off on one machine, makes a hop over HTTP, and then continues on another machine, which is something which is super helpful if you're doing distributed debugging. And you can actually see the source code and variable state between those two machines. You can see the HTTP connection being made and then the jump. into the target machine. And you can see source and variable state across different machines within the stack tray. So this is something that we've added this year for distributed systems. The next goal, and this is a project we're just embarking on right now, which I thought would be interesting to share, is how do we apply this model to reactive applications? One of the biggest things about reactive applications, and doesn't mean it applies if you're using frameworks like Akka or RxJava, and there's a ton of them out there, is essentially that within traditional applications, each user, each process within the JVM has its own unique call stack. So if you look at all the call stacks that are running within a runtime, you can kind of understand what's going on within that application, and that is critical. You can essentially, with Java, take a stack jump of a JVM and know what's going on in there. But reactive programming is changing that and turning that model upside down. We're no longer binding user activities or operations within the system to an OS thread, which means traditional tools for debugging systems no longer work. A thread dump for an application that's built on reactive programming principles can be fairly meaningless, because all the activities, everything that's in flight, all the things that that JVM, that application is dealing with, if it's using a container like Netty, are no longer bound to OS threads. They're all somewhere defined in the actual monads and the actual data flows defined by that reactive application. And the biggest challenge here is how can we, and this is where we really kind of come in and help, if you will, how can we essentially extend software runtimes to be able to cope and adapt to reactive applications and be able to provide call stacks for those kinds of tools, where those jumps are no longer between machines but within one JVM itself, and you can have 10 jumps. So this is a project that we're working on this year, and we're expecting to launch it in this quarter. And hopefully by the time we meet here next time, I'll be able to show you how essentially Takipi have been able to solve the problem of debugging reactive applications in both Akka and RxJava and Java in general. So with that, thank you very much, guys.